Hello students, in this video we shall see the definition of the concept of context-free grammars and context-free languages. This is the second topic in our module 2. We have already seen the definition of a regular grammar in module 2, and we know that a regular grammar is one in which every rule should have a left-hand side and a right-hand side. So the left-hand side consists of a single non-terminal, whereas the right-hand side can consist of symbols like epsilon, a single terminal, or it can be a single terminal followed by a single non-terminal. The format of the rule is x tends to y, where x stands for the left-hand side and y stands for the right-hand side. So we can take some examples of the regular grammars, which can be written as something like A tends to WB. This is a case where a single terminal is followed by a single non-terminal. Or we can have a rule like A tends to W. This is a case where there is only a single terminal in the right-hand side. And then we can have A tends to epsilon. So this is a case where we have only a epsilon symbol on the right-hand side, whereas the left-hand side consists of only a single non-terminal. Just like a regular grammar, the context-free grammar also has got two parts in its rule, in each of its rule. That is, the left-hand side consists of a single non-terminal, and the right-hand side can have any sequence of symbols, that is, a mixture of non-terminals and or terminals. So the format of the rule we know is x tends to y. So the left-hand side of the rule consists of only non-terminal, a single non-terminal, whereas the right-hand side of the rule really does not have any restriction. So there is no restriction on the type of the symbols which can appear in the RHS. We shall take a few examples of rules which can be categorized as valid and not valid rules. So first we'll consider a set of valid rules. S tends to epsilon. Now we can see that there is a special symbol epsilon on the right hand side, and this is allowed. Null string is allowed on the right hand side of a CFG. S tends to A. This is an example where we have a single terminal on the right hand side. Even this is valid. S tends to capital T. Even this is valid because we are having a single non-terminal on the right hand side. S tends to ASB. Even this is allowed because it's a combination. This is an example of a combination of terminal and non-terminals. Another example can be something like ASB, TT, A, B, etc. So even this is valid. This is also a combination of terminal and non-terminal symbols. We shall see a few invalid rules. ST tends to ASB. This is invalid. Why it's invalid? Because in the left hand side we have got two non-terminals. The rule tells us that we should have only a single non-terminal on the left hand side. Next, A tends to ASB. Even this is not valid because we are having a terminal symbol on the left hand side. Even this is not valid. Next, epsilon tends to ASB. Even this is invalid. We cannot have special symbols like epsilon on the left hand side. So left hand side should consist of only a single non-terminal. The different types of notations which we can use while constructing grammars can be like this. We know that rules have got terminals and non-terminals. So, terminals can be keywords like if, for, while, do while, etc. Then we can have digits from 0 to 9. We can have operators, or we can also call them as symbols. Symbols like plus, minus, star, divide operator, etc. All lowercase letters are considered as terminals. Among the non-terminals which we can have, we first consider the uppercase letters. Then we can have names like maybe expression, or it can be an operator, or a name like operand, or statement, etc. We are talking about names here, or terms which can be replaced. These expression, operator, operand, statements, etc. will have to be replaced by terminals. So these can be a few notations which can be used while constructing rules in grammars. A grammar is called context-free because using these rules, the decision to replace a non-terminal by some other sequence is made without looking at the context in which the non-terminal occurs. We'll take an example to understand this concept. Consider that we have a set of rules like S tends to ASB, S tends to AS, S tends to PS, S tends to epsilon. Now we can see that in the RHS of the rule we have a non-terminal, that is S, and S will have to be replaced by its corresponding production body in order to derive any string. Now consider that we have to derive a string AAA, BBB. How will we obtain this string? In order to obtain this string, we have to take rules and check whether, take each rule and check whether we can obtain this resultant string. And to obtain the resultant string, we always have to start with a start symbol. So here in this set of rules, we'll consider S as the start symbol. So start symbol along with its production body, that is the entire start rule, will have to be considered in order to start the derivation. So let me take the first way of deriving the string. I will take the start symbol S and I'll take the first production rule ASB. We know that we have to replace this S. So I will replace this S with the rule number 1 itself. AS, B. Again, we know that S is the non-terminal which has to be replaced. So it is ASB, BB. Again, I have taken rule number 1. And then finally, I take rule number 4, that is S tends to epsilon, in order to obtain the string. So I got the string which is required, AAA, BBB. Now here, when we derived this, we did not see the context of the rule. We just replaced S by the required string. We can generate this AA, A, B, B, B through other replacements too. For example, if this is one way of deriving, I'll take another example of derivation. We can take the second rule. Instead of the first rule, we take the second rule. S derives AS. Now here we see only this S. We do not see the context in which S appears. So this S can be replaced by AS. That is the second rule. Again, I'm going to just replace AA, AS. Now this S can be replaced by the third rule, AAA, BS. Now this S I'll replace by the third rule again. So I get AAA, BBS. Again I replace this S with the third rule. And then finally I use the fourth rule in order to obtain the string AAA, BBB. We also can use another way to derive the string. I'll take the first rule, that is ASB, and this S will be replaced by the second rule. So I'll use ASB. Now this S will be replaced by the second rule again. So I have AA, ASB. This S is replaced by the third rule, AAA, BSB, and this S can be replaced by AAA, BSB, and this S will be replaced by the fourth rule, that is epsilon. So AAA, BBB. So here also we obtain the string which is required. So we can see that when we decided to replace the non-terminal by some sequence, we did not look at the context in which the non-terminals occur. We just replaced the non-terminal in order to obtain the string. That's why this type of grammar is called as context-free grammar. A grammar is called as context-sensitive grammar because its rules allow context to be considered. For example, consider rules like S tends to ASB. Then we have AS tends to epsilon. Then we have ASB tends to BSA. Okay, consider this scenario. Now we start off with the derivation as S tends to ASB. Now if you look at the left hand side of this rule, we have got AS and then we've got ASB. So if we see this AS here, we can replace this by an epsilon. Or if you see ASB, then we can replace this by BSA. Now here what do? We take into consideration the context in which S appears. So here for a rule like ASB tends to BSA, what we do with this S? We have to take into consideration the terminal symbols which appeared before and after. That is, we consider the context. Now suppose we have another rule, something like ASA tends to ATA. Then wherever we have S, we can replace it by T. But we need to consider the symbols before S and after S. symbol before S and after S. Only if the symbol before S and after S is AA, then S can be replaced by T, because here also in this right hand side we have got before T a A appearing and after T a A appearing. So these are the rules where context has to be considered. So such rules are called as context sensitive rules or context sensitive grammars. A context-free grammar, say G, is a quadruple which consists of terms like V, sigma, R and S, where V is a rule alphabet. It's called as the rule alphabet, and this rule alphabet consists of non-terminals and terminals. We know that non-terminals are the symbols which are used in the grammar, but they do not appear in the strings in the language. That is, non-terminals will be replaced by the terminals in order to obtain the final strings. The second component of the context-free grammar is sigma, that consists of a set of terminals, and it is actually the subset of V. The third component is the set of rules. The set of rules is a finite subset consisting of the format V minus sigma cross V star. And the fourth component is S, the start symbol, which can be any symbol from the set V minus sigma. Now the third component of the quadruple, that is R, this is the representation, or this is a component which distinguishes the context-free grammars from the other types of grammars which are there. We know that any rule has got a left hand side and a right hand side, right? So left hand side has to be a non-terminal and the right hand side can be non-terminal and it can be terminal. It's a combination of terminals and or non-terminals. So we'll just write a list of rules. So here we can have S tends to epsilon, S tends to A, S tends to SA, or we can also write S tends to AS. We can write S tends to ASB, S tends to A, etc. So, but one thing to notice, whenever we have a single non-terminal in the right hand side, then this non-terminal should have its corresponding production body also specified. So we know that the right hand side is called as the production body of a rule and the left hand side will be called as the production head of the rule. Now what is a context-free language? A language L is considered as a context-free language if it is generated by some context-free grammar. And a context-free language, that is a CFL, is a proper superset of the regular language. So we can conclude that all regular languages are context-free languages, but not all context-free languages are regular. This is justified with the help of a diagram. So you can see here that the innermost circle consists of regular languages, which would be a subset of the context-free languages. So we can conclude that all the context-free languages are not regular, but all regular languages can be context-free languages. To summarize, we consider a context-free grammar, that is a CFG, to be a grammar in which each rule will have a left-hand side consisting of a single non-terminal and a right-hand side having any sequence of symbols. It can be any sequence of non-terminals and or terminals. There is really no restriction on the type of the symbols which appear on the right-hand side. It can be a mixture of non-terminals and or terminals. A language L is considered as context-free if it is generated by some context-free grammar. And a context-free grammar G is a quadruple consisting of 4 components: V, sigma, R and S, where V is the rule alphabet consisting of non-terminals and terminals, and sigma is a set of terminals, R is a set of rules, and S is the start symbol of the context-free grammar. Thank you.